negative building pressure, and special and custom. Exciting stuff. Train's coming. Air curtains are classified in two different types. We talked about non-recirculating, mostly common horizontal mount. That's, and we've seen vertical, but Costco you see them. And then, I'm sorry, that's the regular air curtain. Recirculating is the one that you find at Costco, for those who go to Costco, that blow across the coolers where the eggs are. Most common are horizontal mount, and vertical mount are the ones at Costco. So the horizontal mount basically throws air right above, and then it blows the air down. And again, like Dave said, it has to clear across the full height and width of the opening. Okay? That's the vertical. The major difference is the pathways, cabinet construction. As you know, when you put something vertically, it's not always good when it's on a horizontal air curtain. Sometimes it is, but you have to make sure, depending on the bearings and the type of materials and heaters you have in there. A range of effectiveness, as David covered before, for taller doors that are really wide, you might have seen it where it's all over, where you go from like this opening, say it's 50 feet high by 100 feet wide. You can go here and then here as well. So it depends on the application. Those are more like hangers. So, and again, the range of effectiveness and purchase. These are just the differences that we have. Installation cost. And we're going to go over the differences a little later. So we're going to start with non-recirculating, which is what Dave and I mainly do. It draws air from the surrounding, and then it blows it right to the discharge. It's basically in and out. Like I said, non-ducted. It can be ducted to a certain point, but sometimes it's necessary for adding heat that they have for a special source, and also adding cooling as well. If the equipment draws from surrounding, it's still considered non-recirculating, even though it's ducted, because it's mostly just for providing enough air for it. So it can be recessed as well. If you walk through the doors where you just see the slot, it looks like linear slot diffusers. That's just the air curtain up there because no one wants to see it. It's architects and they like that, so they don't want the actual equipment being seen. So it can be used for flight control. That's one of the main application because they don't like the turbulent jetties for the fly, like Dave said. And again, we have to be, we even ask for birds, preventing birds from coming in, larger bugs. So it depends on the application, how tall the installation is. It can work to a certain extent. Okay, the most commonly used due to initial purchase price. That means it's a very relatively cheap product for the amount of savings, and you're going to, for that particular application, especially small mom and pop shop. That's really it's more beneficial for them. Typically used for special application due to flexible construction, smaller size, and installation. Again, easy to use, readily available, and can be pretty much installed anytime, anywhere. And normal power. You don't have to have special power or special ducting. Recirculating. Again, great product. Draws air from ductwork, collects it. Like I said, it trains its own air. In this version that we have here, the majority of the application use plenum, usually at the floor or on the side. What it does there is it blows the air down and it gently pulls it on the bottom. So it's a push and pull type. And then you see the air handler. That's where fans can be, heaters, filters, etc. And sometimes they have multiple motors, one on the intake and one on the discharge. Again, I recommend for openings with extended period of time. That means that they never close the door and it's always open. Again, that's the Costco, which is a good example. Higher energy rating. That means it's a little bit higher effectiveness. That means that it's just because it's typically inside, and there's not a lot of things blowing through it. No air pressure. Again, lower air streams, less intrusive. I'm going to go over the difference a little later. Recessed components are perceived less obtrusive as well. So again, it's all what you're looking for, what your application, how much you're willing to spend. And here's some of the differences. We should go over real quickly. Non-recirculating, low planning installation. Like I said, you can go to the store right now and buy one. For the recirculating, it's very high cost. You cannot just buy one. It takes months of planning. And you saw the trough on the other one. You have to plan ahead and dig it up, get enough power to do it. And again, the non-recirculating, you can retrofit it to existing opening. It can be used for fly insect control and temperature control, so it's one air curtain. And again, the disadvantages. It could be perceived as intrusive. It uses a little bit higher velocity, less effective because of just the split that Dave was talking about at the floor. And then again, it's not recommended if you have an opening that's just open continuously. It is really not intended for that. It's the balance issue. Some people say 5 to 10 minutes, but typically you want it open and you want it closed. And the disadvantage of recirculating a very, very high cost. We're talking about thousands of dollars, way above the air curtain. Requires planning and installation before you install it. Typically, you have to get that spec'd in way ahead of time. It's not intended for fly control because it has low velocity, and it's just a special niche market, and it's really specialty. But again, there's some people that just spec it, and that's all that they want to use.
It's not supposed to be high.
I know. Sorry.
That's my fault.
All right, so there's 7 types we talked about. We have exterior environmental separation. That just means when you open the door from outside, you go in. The air curtain blows out, prevents any type of dust-borne, wind-borne debris, flies, temperature from outside. You want to keep it from coming in. Interior, that means you have an office or you have a production facility and you open an office door. You don't want that dust, fume, debris from coming in, etc., whatever it is. Again, it can be controlled automatically. It's very, very easy, small for exterior application. Flying insect control, that's a fly fan. It's pretty normal. He went through that in great detail. So process control again, the requirements, there they are for NSF, front door, back door, slightly different. And inspectors typically will accept any air curtain that are NSF, but they have different classifications. Okay, so, and coolers, chillers, again, these are just specialty applications that we have as well. Prevent that cold air from being reduced. Sometimes the temperature is required by code or by law to go a certain level only. If they do, it's really a big problem. They have to, if it's food facility, they have to throw away that food because it's a safety issue. Typical, not limited to indoor application. It can be for outdoor application, but you have that delta, the temperature delta. It is really not a great application when you have hot, humid outside and then cold and dry inside. And again, horizontally mount, again, difficult to balance on vertical. Just a lot of adjustments. That's something that the manufacturer can typically help you out. Ovens is another good example. You have an oven that's very hot and it's blasting towards the outside, and so people can't walk across it. So we use an air curtain to blow typically up or side, because if you put it on top, it's just going to burn the material. Like Dave said, you have to look at construction. What is it made of? How hot is the insulation area? So just little things to consider when you're making the selection. Negative pressure, that's always been a battle for us. We talked about that. This is something that people think that they can solve it with an air curtain that's typically under 1,000. It's impossible. It has become, Dave said, it becomes a duct heater. It just tempers the air that's coming in because we can't solve your building issue. That's the best we can do. In some conditions, it can help, but it can never get away from that because that air is going to come in regardless. We're just going to temper it. And some of the specialty, we've done, cooling in the bottle. We've heated the tires so you can put it on rims. Little things like that. We've blown butterflies off trees. So a lot of specialty application that's really available out there. And again, you can contact the manufacturer to get more details. The benefits of air curtain. We talked about that. Proven, it's retain energy. There's studies out there that's being already been done that shows that. Reduces the load of the heating and cooling equipment. That means it's not working as hard. You don't have to oversize it. Have you ever gone to those places where you open a door, it opens out, or it's hard to open? They're oversizing it just to make sure that you don't get infiltration. That's wasting energy. It protects the building from windborne dust, contaminants and fumes, etc. that we talked about. And then enhances your experience. You always want to go to a nice place that's comfortable. That's not too cold, too hot. And especially when you're eating out, you have an open patio. You don't want all those flies coming in as well. And then, to some extent, increases safety and productivity of the people working in and around the area. Research, again, we're a little short on time, so these are some of the research that we've done. It's called Investigation of Building Impact on Interest and Whole Building Energy Use. Dr. Wong was very good at creating the study and working with us. And you know, what we did is we asked them to test several things where it's a single door, an air curtain with a single door in a vestibule. And he did it based on a study from Dr. Yule and simulated it. And what he found was that whole building energy consumption was reduced 0.3 to 2.2%. Again, it doesn't seem like a lot, but you're talking about whole building energy consumption, not just over the opening. And again, that study is available if you want to review. It's about 80 pages, I think. And again, we were excited to do it, but we were also scared because we didn't know what was going to happen. We didn't know we need good results, bad results. We just said, here's the boundary conditions, here's the air curtain, pick what you want to use, what you feel is right, the velocity that you feel will work. And then luckily, it all fell in line with what we think and what we thought was the right, you know, to some extent, the right configuration and setup for the air curtain. And then that led to 3 subsequent studies to consider for validation. So again, if we had bad results, we probably would have never done the second one. Energy impact on air curtains in commercial building. We expanded it. Instead of just numerical testing, we did empirical testing. So this is pretty, where's the laser in the middle? Oops. Top button, okay. Yeah, so this is actually exciting. It's a PIV, so it's a particle image velocimetry. It's a little laser that points it at this opening, and they actually had to mold a little 3D print, a little nozzle, so they can get the helium soap bubbles with the right consistency. So when you turn off the light and we get our UV glasses on, he turns it on, you can actually see the airstream moving, and it's pretty interesting. Very cool, and a lot of the students here, they did a great job. It's basically a scale test of the test from Dr. Yule. And again, that's something that was set up in a lab. And some of the results are in the trains here. The results here from the PIV, if you look at the very top, this is the actual, and this is the empirical. So this is basically outflow, meaning the air is blowing out from the pressure inside. This is neutral, that means it's pretty balanced.